Hi everybody, welcome back to my videos. And in today's video we're going to continue with Ubuntu doing command lines. So just a reminder, please, if you like my content, please give a thumbs up, and also click subscribe if you want to subscribe for further content, and also click that bell if you want to get notifications on future content. Alright, so we're continuing on part 2 of command lines in Ubuntu, and we are up to on our Linux command line for beginners. Text, moving and manipulating files. So what to say? Now that we've got a few files, let's look at the sort of day-to-day tasks you might need to perform on them. In practice, you'll still most likely use a graphical program when you want to move, rename or delete one or two files. But knowing how to do this using the command line can be useful for bulk changes or when the files are spread amongst different folders. Plus, you'll learn a few more things about the command line along the way. So let's begin by putting our combined.txt file that we created in the last video into our dir1 directory using the mv move command. So as you can see around here, there's our combined.txt file. So we're going to use the following command. So mv combined.txt space dir1. So if we go ls dir1, it shows us that the combined text is in directory number 1. But if we just do normal ls, it's no longer in the tutorial folder. You can confirm that the job has been done by using ls to see that it's missing from the working directory. Then cd dir1 to change it to directory 1. ls to see that it's in there. Then cd ... to move the working directory back again. Or you could save a lot of time by bypassing a path directly to the ls command to get straight to the confirmation you're looking for. So ls dir1. Now suppose it turns out that the file shouldn't be in dir1 after all. Let's move it. So it should, you moved it to dir1, but it shouldn't actually be in dir1. Let's move it back to the working directory. We could cd into dir1 and use mv combined.txt ... to say move combined.txt into the parent directory. But we can use another path shortcut to avoid changing directory at all, in the same way that the two dots represent the parent. So directory. So a single dot can be used to represent the current working directory, because we know that there is only one file in dir1. We can also use the star to match any file name in that directory, saving ourselves a few more keystrokes. A command to move the file back into the working directory therefore becomes this. Note the space before the dot. There are two parameters being passed to the move command. So mv dir1 / star space dot. So this should, the mv command also lets us move more than one file at a time. If you pass more than 2 arguments, the last one is taken to the destination directory and the others are considered to be files or directories to move. Let's use a single command to move combine.txt, all our test env text files, and dir3 into dir2. There's a bit more going on here, but if you look at each argument at the time, you should be able to work out what's happening. So we're going to go move combined dot txt space test underscore star to represent the number dot txt. No, we don't need to do that. dir 3 dir2. Right, so enter on that, and then we go ls. So we should see dir3 missing, the test files missing, and the output, the combined file missing as well. So we'll go ls dir2. So there we go. So we've got directory 3, test1 combine.txt, directory 3, test underscore 1.txt, test underscore 2.txt, and test underscore 3.txt. With combine.txt now moving into dir2, what happens if we decide it's in the wrong place again? Instead of dir2, it should have been put in dir6, which is the one that's inside dir5, which is inside dir4. With that, we now know about paths. That's no problem either. So what we're going to need to do is mv dir2 / combined .txt dir4 / dir5 / dir6. So we'll return on that, and then we'll go ls dir2. So that shows us that combine.txt has been moved. So we need to look into, so ls dir4 / dir5 / dir6, and it shows us that combined text is in directory 6. So notice how our mv command lets us move the file from one directory into another, even though our networking directory is something completely different. This is a powerful property of the command line. No matter where in the file system you are, it is still possible to operate on files and folders in totally different locations. Since we seem to be using and moving that file a lot, perhaps we should keep a copy of it in our working directory. Much as the mv command moves files, so the command cp copies them again. And note the space between space before the dot. So cp for copy dir4 /dir5 /dir6 /combined.txt / dot. So ls dir4 /dir5 /dir6, and that the combined text is still in there, and then ls, and combined text is also still in the working directory. So great, now let's create another copy of the file in our working directory, but with a different name. We can use the cp command again, but instead of giving it a directory path as the last argument, we'll give it a new file name instead. So we go cp combined.txt space backup underscore combined.txt, and then ls. So we've got a backup file. That's good, but perhaps the choice of backup name could be better. Why not rename it so that it always appears next to the original file name in a sorted list? The traditional Unix command line handles a rename as though you are moving the file from one name to another, so our old friend mv is the command to use. In this case, you just specify two arguments, the file you want to rename and the new name you wish to use. So mv backup underscore combined.txt space, and I'm going to rename it combined underscore backup dot txt, and then ls. Right, this also works on directories, giving us a way to sort out those difficult ones with spaces in the name that we created earlier. To avoid retyping each command after the first, use the up arrow to pull the previous command in the history. You can then edit the command before you run it by moving the cursor left and right with the arrow keys, and removing the character to the left with the backspace, or the one with the cursor with delete. Finally, type the new character in place and then press enter or return to run the command once you've finished. Make sure that you change both the appearances of the number in each of the lines. So mv folder 1 space folder underscore 1. So Hi, can anybody see what I've done there? If so, I'll give you a few seconds to write in the comment section. Right, so what I've done is, when I've gone to do folder 5, instead of deleting the 4, I've left the 4 in. So I've tried to and there we go. So we've got folder underscore 1, folder underscore 2, folder underscore 3, blah blah blah, to folder underscore 6. So now we're going to delete files and folders. So in this section, we're going to start deleting files and folders. To make absolutely certain that we don't accidentally delete anything in your home folder, use the pwd command to double check that you're still in the TMP tutorial directory before proceeding. So pwd. So we're in the TMP tutorial. Now we know how to move, copy and rename files and directories. Given that these are just test files, however, perhaps we don't really need 3 different copies of combined.txt after all. Let's tidy up a bit using the rm, so remove command. So we go rm dir4 Oh, what have I done there? Again, at this point, write in the comment section what you think I've done wrong there. I'll give you a good 20 seconds. Here we go. Okay, so what I've done is I've actually put an extra dir in the text. So I'll just press up to bring that text back up and delete that. So this is why it's good to double check your work. Huh. Okay. Strange. Because I'm sure, unless I've missed a point there, perhaps we should remove some of those excess directories as well. So rm folder underscore star. So all the folders with the underscore, and then boom, rm cannot remove folder underscore 1, cannot remove what is a directory. What happened there? Well, it turns out that rm does have one little safety net. Show you can use it to delete every single file in the directory with a single line command, accidentally wiping out thousands of files in an instant, which means to recover them, but it won't let you delete a directory. I suppose that does help with preventing deleting thousands more files, but it does seem a little petty for such a destructive command to be bulk at removing an empty directory. Luckily there's an rm dir remove directory command that will do the job for us instead. So instead of make directory, we're going to rm dir and then folder underscore star. Failed to remove folder 6 directory not empty. Right, I don't know why I couldn't remove the combined backup text, right? So because I didn't do the command properly. So remove rm dir4 dir5 dir6 combined.txt space combined underscore backup.txt. Alright, add on then. Let's have a look. So ls dir4 dir5 dir6. Right. Okay, so it hasn't deleted dir folder 6. Right, hold on then. So, right, hold on. Well, that's a little better, but there seems to be there. If you run ls, you'll see that most of the folders have gone, but folder 6 is still hanging around. As you may recall, folder 6 still has a folder 7 inside it, and rmdir will only delete empty folders. Again, it's a small safety net to prevent you from accidentally deleting a folder full of files when you didn't mean to. In this case, however, we do mean to. The addition of options to our rm or rmdir command lets us perform dangerous actions without the aid of a safety net. In the case of rmdir, we can add a -p switch to tell it to also remove the parent directories. Right, so think of it as a counterpoint to mkir-p. So if you were to run rmdir/p, dir1, dir2, and dir3, it would do firstly dir3, then dir2, and then finally delete dir1. It still follows the normal rmdir rules of only deleting empty directories though. So if there was also a file in dir1, for example, only dir3 and dir2 would get removed. A more common approach when you you're really sure that you want to delete a whole directory and anything within it, is to tell RM to work recursively by using the -R switch, in which case it will happily delete folders as files as well. With that in mind, here's the command to get rid of that pesky folder 6 and the subdirectory within it. So RM -R folder _6 ls. So there we have. There. Remember, although RM-R is quick and convenient, it's also dangerous. It's safest to explicitly delete files to clear out a directory, then cd ... to the parent directory before using rmdir to remove it. Warning. Unlike graphical interfaces, RM doesn't move files or folders called trash or similar. Instead, it deletes them totally, utterly, and irrevocably. You need to be ultra careful with the parameters you use with the RM to make sure that only deleting the files you intend to. You should take particular care when using wildcards, as it is easy to accidentally delete more files than you intend. An errant space character in your command can change it completely. RMT* means delete all the files starting with T, whereas RMT * means delete the file T as well as any file whose name consists of 0 or more characters, which would be everything in that directory. If you're at all uncertain, use the -I interactive option to RM, which will prompt you to confirm the deletion of each file. Enter Y to delete, N to keep, and press Ctrl+C to stop the operation entirely. So that there is moving and manipulating files. So next we're going to move on to a bit of plumbing. So a bit of plumbing. Today's computers, the phones have this. Today's computers and phones have the sort of graphical and audio capabilities that our 70s terminal users couldn't even begin to imagine. Yet still text prevails as a means to organizing categorized files, whether it's a file name itself, GPS coordinates embedded in photos you take on your phone, or the metadata stored in your auto file. Text still plays a vital role in every aspect of computing. It's fortunate for us that the Linux command line includes some powerful tools for manipulating text content and ways to join those tools together to create some more capable still. So we'll start with a simple question. How many lines are there in your combined.txt file? Please write in their comments. The WC or word count command can tell us that using the -L switch to tell it we only want the line count. Right, I'll read that bit again. So the WC or word count command can tell us that using the -L switch to tell it we only want the line count. It can also do character counts and as the name suggests, word counts. So this command would be WC space -L combined.txt. So 3 lines in combined.txt. Similarly, if you wanted to know how many files and folders are in your home directory and then tidy it up after yourself, you could do this. So ls to add space greater than or less than file space in file underscore list dot txt wc dash l file underscore list dot txt. So it says there's 9 lines in the file underscore list dot text, and then rm file underscore list dot txt. That method works, but creating a temporary file or folder, creating a temporary file to hold the output from the ls only to delete it 2 lines after seems a little excessive. Fortunately, the Unix command line provides a shortcut that avoids you having to create a temporary file by taking the output from one command, referred to as the standard output or std out, and feeding it directly in as the input to another command, standard input or stdin. It's as though you've connected a pipe between one command's output and the next command's input, so much so that this process is actually referred to as piping the data from one command to another. Here's how to pipe the output of our ls command into wc command. So ls to add, I'm going to find it again, there we are. Right, what kind of character is that? Is that a L, or is it I don't think I have this type of marker. It's a line going from top to bottom. Can anybody tell me where that would be on the keyboard? Would it be that? There we are. Right, I've found it anyway. It's on the left hand side next to the shift, but you need to use shift to use it. So wc dash l 9. Notice that there's no temporary file created and no file name needed. Pipes operate in Italian memory, so most Unix command line tools will expect to receive an input from a pipe if you don't specify a file for them to work on. Looking at a line above, you can see that it's 2 commands, ls, which is the list of contents of your home directory, and wc-l, which counts a line separated by a vertical bar character, which is the line that I asked about. This process of piping one command into another is commonly used that the character itself is often referred to as the pipe character. So if you see that term, you know it just means the vertical bar. Note that the spaces around the pipe character aren't important. We've used them for clarity, but the following command works just as well, this time for telling us how many items are in the etc directory. So ls/etc vertical bar wc space -l. So there are 227 items. So a few. That's a few files. If we want to list them all, it would clearly fill up more than a single screen. As we've discovered earlier, when a command prompt produces a lot of output, it's better to use ls to view it. And that advice still applies when using a pipe. Remember to press Q to quit. So ls/etc vertical bar less. So we press the Q to quit. Going back to our own files, we know how to get a number of lines in combine.txt, but given that it was created by concentrating the same files multiple times, I wonder how many unique lines there are. Unix has a command unique that will only output unique lines in the file. So we need to cut the file. Cut the file out and pipe it through the unique. But all we want is a line count, so we need to use the WC as well. Fortunately, the command line doesn't limit you to a single pipe at a time, so we can continue to chain as many commands as we need. So I'm assuming, because I haven't done this, so cat combine.txt tar unique, not to add, vertical bar less. So this is a test and this is a third. I know why it's only come up with them two. I should have had this as a second test, but when I did the original file, it I put this as a test twice. It appears that very few, if any, of our duplicate lines are being removed. To understand why, we need to look at the documentation for unit command. Most command line tools come with a brief and sometimes not so brief instruction manual accessed through the MAN or manual command. The output is automatically piped through your pager, which will typically be less, so you can move back and forth through the output. Then press the Q when we're finished. So MAN unique. So manual page 1, line 1. Right, because of this type of document is accessed via the man command, you'll hear it referred to as a man page. As in, check the man page for more details. The format of the man pages is often terse. Think of them as more quick overview of a command than a full tutorial. They are often highly technical, but you can usually skip most of the content and just look for the details of the option or argument you are using. The unique man page is the typical example in that it starts with a brief online description of the command, moves on to the synopsis of how to use it, then has a detailed description of each option or parameter. But whilst man pages are invaluable, they can also be impenetrable. They're best used when you need a reminder of a particular switch or parameter. rather than as a general resource for learning how to use command line. Nevertheless, the first line of the description section for man Unix does not answer the question as to why duplicate lines haven't been removed. It only works on adjacent matching lines. The question then is how to rearrange the lines in our file so that the duplicate entries are on adjacent lines. If we were to sort out the contents of the file alphabetically, that would do the trick. Unix offers a sort command to do exactly that. A quick check of a man sort shows that we can pass a file name directly to the command. So let's see what it does to our file. So, sort combined .txt vertical bar less. Oh, helps if I wasn't in the manual still. So sort combine.txt vertical bar less. This is a test, this is a test, this is a third test. Right, okay. Right, you should be able to see that the lines have been recorded, now suitable for piping straight into Unix. We can finally complete our task of counting unique lines in the file. So sort sort combined .txt / vertical bar / unique space, don't know why I was saying / vertical bar wc space -l 2. As you can see, the ability to pipe data from one command to another, building up a long chains of multiple to manipulate your data, is a powerful tool, as well as reducing the need for temporary files and saving you a lot of typing. For this reason, you'll see it used quite often in command lines. A long chain of commands might look intimidating at first, but remember that you can break even the longest chain down to the individual commands and look at their man pages to get an even better understanding of what it's doing. So many manuals, mostly in the command line tools include a man page. Try taking a brief look at the pages for some of the commands you've already encountered. So man ls, man cp, man rmdir, and so on. There's even a man page for the man program itself. Wow. Which is accessed using man, of course. Alright, so now we're going to move on to the command line and the SuperUser. Log back onto the computer. Turned off for some reason. Right, one good reason for learning some command line basics is that the instructions online will often favour the use of shell commands over the graphical interface. Where those instructions require changes to your machine that go beyond modifying a few files in your home directory, you will inevitably be faced with commands that need to be run as a machine's administrator, or SuperUser in Unix parlance. Before you start running arbitrary commands, you'll find in some dark corner of the internet it is worth understanding the implications of running as an administrator and how to spot those instructions that require it, so you better gauge whether they're safe to run or not. The SuperUser is, as the name suggests, a user with superpowers. In older systems, it was a real user with a real username, almost always known as root, that you could log in as if you had the password. As for those superpowers, root can modify or delete any file in any directory on the system, regardless of who owns them. Root can rewrite firewall rules or start network services that could potentially open the machine up to attack. Root can shut down the machine even if other people are still using it. In short, root can do just about anything, skipping easily around the safeguards that are usually put in place to stop users from overstepping their bounds. Of course, a person logged in as root is just as capable of making mistakes as anybody else. The annals of computer history are filled with the tales of mistyped command deleting the entire file system or killing a vital server. Then there's the possibility of a malicious attack. If a user is logged on as root and leaves their desk, then it's not too tricky for a disgruntled colleague to hop onto their machine and wreak havoc. Despite that, the human nature being what it is, many administrators over the years have been guilty of using root as their main or only account. Don't use the root account. If anybody asks you to enable root account or log in as root, be very suspicious of their intentions. In an effort to reduce these problems, many Linux distributions started to encourage the use of the su command. This is variously described as being short for SuperUser or SwitchUser, and allows you to change another user on the machine without having to log out again. When used with no arguments, it assumes that you want to change the root user, hence the first interpretation of the name. But you can pass a username to it in order to switch a specific user account, the second interpretation. By encouraging use of the SU, the aim was to persuade administrators to spend most of their time using normal account only, using a normal account, only switch to the SuperUser account when they needed to, and then use the logout command or Control-D shortcut as soon as possible to return to their user level account. By minimizing the amount of time spent logged on as root, the use of SU reduces the window of opportunity in which to make a catastrophic mistake. Despite that, human nature being what it is, many administrators have been guilty of leaving long-running terminals open in which they've used SU to switch to the root account. In that respect, SU was only a small step forward for security. If anybody asks you to use SU, be wary. If you're using Ubuntu, the root account is disabled by default, so SU with no parameters won't work. But it's still not worth taking the risk in case the account has been enabled without you realizing it. If you are asked to use SU with a username, then if you have the password, you will have access to all the files of that user and could accidentally delete or modify them. So, when using the SU, your entire terminal session is switched to the other user. Commands that don't need root access, something as mundane as pwd or ls, would be run under the auspices of the super users, increasing the risk of a bug in the program causing major problems. Worse still, if you lose track of which user you are currently operating as, you might issue a command that is fairly benign when run as a user, but which could destroy the entire system if run as root. Better to disable the root account entirely, and then, instead of allowing long-lived terminal sessions with dangerous powers, require the user to specifically request SuperUser rights on a per-command basis. The key to this approach is called sudo, as in switch user and do this command. Sudo is used to prefix a command that that has been run with the SuperUser privileges. A configuration file is used to define which users can use sudo and which commands they can run. When run a command like this, the user is prompted for their own password, which is then cached for a period of time, defaulting to 15 minutes. So if they need to run multiple SuperUser level commands, they don't need to keep getting continually asked to type it in. On an Ubuntu system, the first user created when the system is installed is considered to be the SuperUser. When adding a new user, there's an option to create them as an administrator, in which case they will also be able to run SuperUser commands with sudo. In a screenshot of Ubuntu 18.4, you can see that option on the top of the dialog. Now, I haven't got the ability to show you. That screen. So, assuming you're a Linux system that uses sudo and your account is configured as an administrator, try the following to see what happens when you try to access a file that is considered sensitive. It contains encrypted passwords. So, if we type in cat/etc/shadow, it would say permission denied. But if we type in sudo/cat, not forward slash, sorry, space cat, space /etc/shadow, password. It brings up all that. So I don't know what all that means. Daemon, sysman, LP, mail, news, UUCP, proxy, data, backup list, IRC, NAT, nobody, systemd resolve, systemd timesync, megabus or message bus, syslog. You get the gist. It lists the. So if you enter the password in prompt, you should see the contents of the ET shadow file. Now clear the terminal by running the reset command. So reset. And then run sudo cat etc shadow. This time the file will be displayed without prompting you for a password and is still in the cache. So reset. Be careful with sudo. If you are instructed to run a command with sudo, make sure that you understand what the command is doing before you continue. Running with sudo gives that command all the same powers as a SuperUser. For example, a software publisher's site might ask you to download a file and change its permissions, then use sudo to run it. Unless you know exactly what the file is doing, you are opening up a hole through which malware could potentially be installed on your system. Sudo may only run one command at a time, but that command could itself run many others. Treat any use of sudo as being just as dangerous as logging in as root. So let's install a new command line program from the standard Ubuntu repositories to illustrate the use of sudo. So sudo apt install tree. So this is installed a program. Once you've provided your password, an apt program will print out quite a few lines of text to tell what it's doing. The tree program is only small, so it shouldn't take more than a minute or two to download and install for most users. Once you have returned to the normal command line prompt, the program is installed and ready to use. So let's run it to get a better overview of what our collection of files and folders look like. So cd/tmp/tutorial, just to make sure we're in that folder, and then tree. So folder, okay. I've managed to make a file called Q and art, a text file called art combined. Right, so okie dokie. Going back to the command is actually install a new program, sudo apt install tree. It looks slightly different to those you have seen so far. In practice it works like this. The sudo command, when used without any options, will assume that the first parameter is a command for it to run this with SuperUser privileges. Any other parameters will be passed directly to the new command. Sudo switches all start with 1 or 2 hyphens and must be immediately followed by the sudo command, so there can be no confusion about whether the second parameter on the line is a command or an option. So the command in this case is apt. Unlike the other commands we've seen, this isn't working directly with files. Instead, it expects its first parameter to be an instruction to perform install, with the rest of the parameters varying based on instruction. In this case, the install command tells apt that the remainder of the command line will consist of one or more package names to install from the system software repositories. Usually this would add new software to the machine, but packages could be any collection of files that need to be installed to a particular locations, such as fonts or desktop images. You can put sudo in front of any command to run it as a super user, but there is rarely any need to. Even system configuration files can often be viewed with cat or less as a normal user, and only require root privileges if you need to edit them. So in this section you've learned about the dangers of the root account, and how modern Linux systems like Ubuntu try to reduce the risk of danger by using sudo. But any of the superuser powers should be considered carefully. When following instructions you find online, you should now be in better position to spot those commands that might require greater scrutiny. So next up we're going to go on to hidden files. So hidden files. Before we conclude this tutorial, it's worth mentioning hidden files and folders. These are commonly used on Linux systems to store settings and configuration data, and are typically hidden simply so that they don't clutter the view of your own files. There's nothing special about a hidden file or folder other than its name. Simply starting a name with a dot is enough to make it disappear. So cd/tmp/tutorial, ls, So mv combine.txt space dot combined.txt and then ls again. Right, I'm just gonna right, so I've just deleted a few files because I don't know what I did with them. Right, so you can still work with the hidden file by making sure you include the dot when you specify its file name. So cat dot combined dot txt. So mk dir dot hidden so I've made a hidden file folder. So mv dot combined dot txt to dot hidden and then less dot hidden / dot combined dot txt Right, so I just need to ls dot hidden and there's nothing there. ls right, so if you run ls you will see that the hidden directory, as you might expect, is hidden. You can still list its contents using ls.hidden, but as it only contains a single file, which is itself hidden, you won't get much output. But you can use the -a show all switch to ls to make it show everything in a directory, including hidden files and folders. So ls-a ls-a dot hidden. So we have our combine.txt. Notice that the shortcuts we used earlier, dot and dot dot, also appear as though they're real directories. As for our recently installed tree command, that works in a similar way, except without an appearance by dot and dot dot. So tree and tree-a. Oh yeah, oh yeah. So in the first instance, tree doesn't show the hidden file, folder or file, but in the second one, when you do the -a command in the tree file, it shows the hidden file and folder and file. Right. Switch back to your home directory CD by running and try running ls without and then with the -a switch. Okay, so CD. So ls and ls-a. Whoa, look at all that. Only problem is, where's my TMP folder? Pipe the output through WC-L to give you a clear idea of how many hidden files and folders there have been right under your nose all this time. So WC-L. Oh, hold on, because I have to put the WC-L. Right, so we have to put the vertical line in. Right, so 22. These files typically store your personal configuration and is how Unix systems have always offered the capability to have a system level settings, usually in -etc, that can be overwritten by individual users courtesy of hidden files in their home directory. You shouldn't usually need to deal with hidden files, but occasionally instructions might require you to cd into the .config or edit some file whose name starts with a dot. At least now you'll understand what's happening, even when you can't easily see in the file in your graphical tools. So we're just going to do a bit of clearing up. So we've reached the end of this tutorial, and now you should be back in your home directory, which is correct. Now use pwd, yep, home CWC, to check and cd to go back there if you're not. It's only polite to leave your computer in the same state that we found it in. So as a final step, let's remove the experimental area that we've been using earlier, then double check that it's actually gone. So rm-r//tmp/tutorial and then ls/tmp. Well, I can't see anything there. As a last step, let's close the terminal. You can just close the window, but it's better practice to log out of shell. You can use either use the logout command or the Control-D keyboard shortcut. So Control-D. So we've logged out. If you plan to use the terminal a lot, memorizing Control-Alt-T to launch the terminal and Control-D to close it will soon make it feel like a handy assistant that you can call on instantly and dismiss just as easily. So in conclusion, This tutorial has only been a brief introduction to the Linux command line. We've looked at a few common commands for moving around the file system and manipulating files, but no tutorial could hope to provide a comprehensive guide to every available command. What is more important is that you've learned the key aspects of working with the shell. You've been introduced to some widely used terminology and synonyms that you might come across online, and have gained an insight into some of the key parts of the typical shell command. You've learned about the absolute and relative paths, arguments, options, man pages, sudo and root, hidden files, and much more. With these key concepts, you should be able to make a much more sense of any command line instructions you come across. Even if you do not understand every single command, you should at least have an idea of where one command stops and the next begins. You should more easily be able to tell what files they're manipulating, or what other switches or parameters are being used. With reference to the man pages, you might even be able to glean exactly what the command is doing, or at least get a general idea. Further reading. There are many online tutorials and commercially published books about the command line, but if you want to go deeper into the subject, a good starting point might be the following book, The Linux Command Line by William Schatz. And what I'll do is I'll put that link in the description. And the reason for recommending this book is that it has been released under a Creative Commons license and is available to download free of charge as a PDF file, making it ideal for the beginner who isn't sure how much they want to commit to the command line. It is also available as a printed volume should you find yourself caught by the command line bug and want a paper reference. So that is Ubuntu command lines. That's actually been a learning experience for myself, and hopefully a learning experience for any beginner anybody who's beginning with Ubuntu. So hopefully you've enjoyed this video. Hopefully it's been a great help to you. I would like to remind you, if you do like my content or like this video, please like it, and if you do like my content, please subscribe, and also click that bell for more content. Thank you very much, and I'll see you in the next one.